All right, guys. So I think we should be recording now. We're going to get started. Um, this is week 3, right? And the lab for this week. So we started a little bit of it on Tuesday, and we're going to continue today. So, all right. Yeah, so I think on Tuesday we were looking at the XOR code, right? So just getting that basic operation going. I think we got as far as the encoding of it, right? The encryption of it. So today we're just going to pick up there and continue with it, finish it. That's your first XOR cipher. It's a type of cipher like the OTP for very short pieces of text, right? And then we do have a PDF to go over as well some integrity related problems. So we'll go over that. And if time permits, we'll start the XOR hash, right? So that's an algorithm creating a hash value, and we can try to code that up. And that should be enough for today. All right. Next week, week 4. Wow. Right. So we're really moving fast. I believe we're starting more of symmetric encryption and like block ciphers and things like that. So all right, so we're gonna get started. So let's just kind of, look at things. So we're gonna look at course website, table of contents, just to kind of get situated. So we've done substitution cipher, that's already been done, and we're kind of here, right? So you can expect the homework assignment, very easy. I'll go over that, so it'll be OpenSSL and the coding part today. All right, week 6 is exam 1. So hopefully you're studying, you'll start seeing your assignment grades soon. So I'll start going over that. But yeah, that's kind of the plan. All right, so I'm gonna need to start up the virtual machine. We're just gonna pick up where I left off on Tuesday. Should be pretty straightforward. Okay, so here's our VM, Oracle. Get started. Yep. So remember, all these coding examples are already on the GitHub, so you can get them from there. The code should be complete. Okay. Well, we're gonna finish this one, and then we'll get into like what the assignment document says for this week. So let's go to the terminal. Desktop. Oh, 125, 50. Okay, and we were in XOR first. So that should be our first script. So we've done a lot of it. We just have to do it in reverse, right? So finish up this example. So let's do nano here. XOR first example. Okay, so I'll do a review of where we are with this one and then just pick up from there. Okay, so essentially we're just testing out the XORing function. So we go to the main section. You can see here I have a plain text message. This is a top secret. We printed it. We calculated the length of it, which was 20, printed the length. Then we use that value to generate a key. So we have this function gen key, which generates a byte array of that specific length. This will be something that we will use throughout, right? So we need to have keys, as you guys have determined. I print the key. Then I have an encrypt function, which takes in, the input plain text and the key, and it's going to proceed to XOR it as a byte array. So it'll return that sequence of bits, zeros and ones, and then we're going to print that out. All right, so that's essentially it. So we have two functions. Decrypt, we haven't done that one yet. But given this code already, you should be able to figure it out, right? So you probably can think about how it would work, but we're going to work through it. We have, of course, notice that we need random functions here, right? Remember the concept of random is hard to achieve 100% randomness, but we need to have some kind of randomness. And then so we have this function, we create a sequence of random bits of a specific length, and we just convert it into a byte array. Over here in the encrypt part, we took the plain text, and I introduced, if you hadn't seen this before, a list comprehension, which is where we have a one-liner for a for loop, right? And essentially the idea is we do for I in range of the length of plain, and what would go underneath the for loop after the for loop statement in a list comprehension goes before. So here I'm iterating index by index. So from the plain text message, I'm grabbing each letter. I use some of the code from the substitution cipher, and I run each of those letters through the ORD function, which was, tied to the ASCII table. So that would give me, an integer representation that I could XOR with the key itself that I'm also iterating through via index. So one very interesting thing about these data types is that in memory, they are stored as byte arrays, regardless of what they are. So that's why this works fine for our purposes. So let's go ahead. And so we do this, and this generated a byte array. Now we're going to proceed to do the second part of it, which is the decryption. So let's just go ahead and make sure this code works. We're going to try it. Okay. And let me know if you have any questions. But we're going to go ahead and run this one. So it should be Python 3, for instance. Python 3. And there we are. So we have the key itself, and then we have the byte array. What's great about cryptography, right, is that, you should get the plain text that you provided. Okay. So now we're going to go ahead and do that. So I'm going to use the editor, and we need to focus on the decrypt function. So I'm going to say, this was my cipher. So now I'm going to have decrypted plain. So I'm going to call it decrypted plain, change the variable name just to make sure that I have this. I'm going to invoke the function decrypt, okay? And then the input to this is going to be the cipher and, of course, the key. So I still need to key just like, before, so I can do the XOR operation. And then I'm going to do print decrypted plain, right? So I should get decrypted, just like that, right? So now we need to proceed and look at decrypt, and we need to process it correctly, okay? So I'm going to say cipher comma, and then some kind of a key. All right. Okay. So now we need to take a look at it. All right. So it's going to be similar idea. It makes sense to iterate through. So I'm going to use a list comprehension once again. Okay. And let me know if you have any questions. This, of course, does not return a byte array because now we want plain text. So we don't need that part, but we do need the list comprehension. And then we might do some formatting to it. So in the list comprehension, so for I in range, and it should be what? The length of the cipher, right? So I'm going to do len of cipher. Okay, just like that. Okay, so remember now in the list comprehension, what would go underneath the for loop now goes before it. So index, essentially, right, is what we're iterating through. But we need to grab the cipher itself, right? So it's going to be cipher. Oops, sorry. Cipher, and the corresponding index. And then also we said that the XOR operation is actually this caret symbol. Okay, this caret symbol. And then now, what else? You XOR it with what? With the key, right? The corresponding element of the key. So I'm going to do key I, just like that. You guys see that? And so that's just the XORing of it. So let's take a look. So we have that. And the final part is we're going to convert that into a string. So we're going to use the CHR function. You know, the other one, right? From the substitution cipher, CHR, just like that. So hopefully if this is correct, we'll get a list of letters. And then from there, we can make it into a nice string or something like that. But this should at least now read as the message. I'm going to go ahead and hit Control X, Y, Enter. Hit clear. And there it is, right? So this is a top secret. So we are able to retrieve the message. We can do, better formatting, of course, of it. There should be a quick way to make it into a nice string. Let's try. Yeah, let's do down here, possibly. So decrypted plain. So we're going to say separator equal nothing. And then we're going to say separator dot join encrypted lane. Okay, and I'm going to assign that to SSS. Okay. Here, I'm going to comment this one out. And this is just to have a better presentation of it, but we already achieve our objective. Okay, so let's try this one, see if it works. And there it is. This is a top secret. So I just took a list and joined it into a string. That's just more Python than anything else. Yeah, go ahead, please. Yeah, of course. Yeah, that one's not that important, but if you'd prefer to see something that's, cleaner, you can try that one. Any questions, guys? So that's the example of XOR that we've completed that part, right? Part two. Questions? Nope. All right. So going forward, whenever we now have an algorithm that uses XOR and you have a string and you have some, a key, etc., you can use this construct or primitive to build your algorithm. So at this point, you can assume we've only encrypted one block, but in encrypting a whole message, we have to take the original plain text message, break it up into blocks, and encrypt those and with one of the modes of operations. Yeah, please go ahead. Yeah, sure. All right, so I'll leave it up for a little bit. Did everyone get the code? All right, perfect. All right, so I think, that's, I wanted to finish this, of course, this mechanism. So I think we're ready now to move on to this week's assignment. It is related to integrity, which was the topic. It's very easy with OpenSSL, and I'll walk you through, but let's take a look at that. So let me, whoop, I didn't mean to do that, sorry. Close this font. Yeah, all right. So I've completed that XOR. Now let's take a look at Brightspace, right? And we're going to analyze the homework. Okay, so we have the substitution cipher. You have until September 15 to submit that one. We did it in class. I don't think I'm gonna assign this XOR as a homework because we will do the XOR hash problem. Okay, so this should be where we are. Python XOR hash algorithms. Let's take a look. Yeah, so I have a word problem here. Okay. So let's take a look. And this algorithm is what we discussed on Tuesday. So it's just a matter of implementing it. Okay, so the document says, there we go. Complete the following problems as done in class. Submit a report showing evidence that you completed the Python XOR hash cipher as discussed in class. You need to run it without errors and show evidence of calculating a hash number. Submit a report showing your work and results. So I gave you the definition of a hash function on Tuesday. So what was the definition? Yes, please.
Mapping something of variable length to something of fixed length.
Exactly, right? And that's it. So the fixed length would be the size of the block. That's the fixed length. And then the variable length is the whole message that you need to break into blocks. So really, that's the hard part of this problem. But actually, it's something that you're going to need for encrypting, also for confidentiality. Remember, this is for integrity only. So yeah, so that's something that we will do. Okay, we will do this algorithm. Let me look at the other. I sometimes like to break these homework assignments into like smaller pieces, so it's easier to grade. So this is definitely a homework, but it'll be its own assignment link, right? And that's, so it's just that one. And then let's look at the other one, and then we can decide which one we want to do first. So let's take a look at that's this. Now, hash functions, this is more like the OpenSSL homework, right? So you can see here, lab problems is what we're doing. I have a Word document. These are the slides, right? So the things that I discuss in class, you can take a look here. It's kind of, I provided additional copies. Okay, here we are. So these are some of the examples that we're going to look at. OpenSSL, essentially how to use OpenSSL to hash a few things. Then we're going to flip one bit and see what happens. Yeah, and that's kind of it. So it's very, very brief, but using OpenSSL just to show you how to do some encryption. Remember, OpenSSL is actually way more secure than any Python script I give you. Okay, so keep that in mind. Most of the Python scripts we're doing from scratch are not something you should use for security. They're just for your own understanding. Unless we're using something like PyCryptoDome, that might be a little bit more secure, but ultimately OpenSSL from your Linux operating system is likely to be the most secure. Okay. All right. So yeah, so that's kind of the PDF. Make sure to read through it, but let's just go over the Word document and see, or these lab problems is the same. So let's see what the Word document says. Okay, so you can see it's kind of problems are complete the following problems as done in class. Number one, calculate hashes for plain text for a plain text file using MD5, SHA1, SHA256. So this is what we're going to do. I'm going to create a text file, pretty much like what I did on the first week of the semester. You know, with Nano, I'm going to create a plain text, put some text in it, and then we're going to learn how to hash it via OpenSSL. Number two, calculate hash values using a key and hash algorithm. So it's very similar, but using a key. Number three is kind of the interesting problem here. It's going to be basically corrupting the file, right? So we're going to create a file and hash it before and after corrupting one bit of the file. And we're going to report our results. So if you remember what I said, imagine you have a 3-hour movie and you hash it, and now you have a hash value. And then you just take that whole movie, but you just corrupt one bit of it, right? What you want is for the hash to be totally different. Do you guys see that? So that's essentially what we're trying to prove here, that because that would prove that hashing is very secure, right? Because the idea being, if you're downloading some software to run on your computer, you know, an update, a patch, you want to make sure that there isn't like a malware or something embedded in there, right? So that's the idea, that no one has tampered with the information. All right, so that will be problem number 3, which you can see is pretty obvious. And then problem number 4 is the same idea as before. You're working with your partner. So let's take a look. Yeah, so now that you know how to calculate hash values with OpenSSL, craft an experiment where you could send a file to your classmate with a hash value. Your classmate should validate that the integrity of the file has been maintained. You can use email for this task. But I've added a little complication here to make it harder. You must also encrypt the file before transmitting. This last step would provide confidentiality. So, and notice this is key. Achieve confidentiality and integrity in one shot. So you can only send one email. Does that make sense, guys? So you have to achieve confidentiality and integrity in one shot. Got it? All right. No questions about that? Everyone gets it? All right, great, perfect. And of course, we're still don't worry about securely sending the symmetric key for this lab, as we still don't have the tools to do that, right? So, but at this point, before in the past, I've said, okay, only achieve confidentiality or only achieve integrity. Now I'm saying you can only communicate once, which this will happen a lot of the time, but you need to achieve both at the same time. So if I can see the message, then you've broken confidentiality, and so you didn't achieve the objective. And you must do this with your classmate. Submit a report showing your work and results. Okay. Any questions on this? All right, you can use OpenSSL for all these problems. Okay. So let's go ahead and just walk through the examples on how to use them on the virtual machine. So I will, of course, do like the first 3, and then you guys can repeat problem or do problem 4 with your partner. So pretty easy. This is probably one of the easiest labs. Okay, so we need to create some hashes with MD5, SHA1, SHA256. So I just need to give you, um, I just need to give you the command for this. Yeah, so these should be pretty straightforward. Let's create a plain text message. So I'm going to say nano. I'm going to call this hash test.txt. Hash text.txt. So this is a message to be hashed. The goal is to achieve what? Integrity, right? Integrity. Okay, so that's the goal, to achieve integrity. So I can send them so because when you send this to your partner, you have to send this file and the hash value, right? You guys get that. So you're in your computer, take the file, hash it, and then send the plain text file, the hash. When they receive it, they take that file, hash it, and then compare the hash that they got on their computer to the one that they received via email, and they should match. That's essentially how it works. In the lab assignment, that message cannot be in plain text because you must achieve both pillars at the same time. All right, so let's try it. So Control X, Y, enter. So let me do ls-l. So I'm going to do OpenSSL. So this is the first one with no key, OpenSSL. These are usually called digests. So you'll see this file as DGST -MD5 and then hash text.txt. And there it is. So that's essentially the hash value right here. Does that make sense? That's it. That's problem one. That's a hash value. So obviously, that file could be much bigger, right? And you can play with that if you'd like, try to convince yourself that that's true. Grab text from Wikipedia or something like that. So I'm going to do now, it says to do several. So you guys have heard of MD5, SHA1, SHA256. So I'm going to do OpenSSL, DGST, SHA1. So, okay. So there it is. You got this one, and then you got this one. And then we can do a third one, which is SHA256. And what do you notice about the SHA256 one? You should notice it's a bit longer. And that's the idea. A lot of the time, with security, you just make things longer without being too long because it's going to affect performance, which is a key thing, and speed. Okay, guys? And you can, try this. So that's problem one. Very easy, just to illustrate how OpenSSL works. Any questions about it? All right, we're going to do the next one then, which should be a key one. Okay, so you now have some kind of a key. So I'm going to repeat with the same file. I'm going to clear these. And it's going to be open SSL DGST -MD5 -HMAC And then you can try something. I'm just going to use A, B, C, D, F, G. A, B, C, D, E, F, G. Okay, as some kind of a key. And then the same file, hash test txt. So this is just another way of computing this. Oh, I think it's text. Yeah, there we are. So you can see that's another way you create your hash value. That's it. So, again, here your two output files would to be transmitted via email to achieve integrity are the hash text.txt, and then this value. This is the value that on the other end, right, the user needs to corroborate. You can see they're both the same, right? They're both exactly the same. So you can assume Bob does this, sends these, and then Alice repeats the task, and she should get the same value, match, therefore integrity has been achieved. And we want to prove that if even just one bit of this is changed, then we get not just a slightly different MAC, but a completely different MAC address. And that's essentially the idea. Any questions on integrity? Is this making sense? Yeah, go ahead. Mhm. Exactly. That's the key. And I said in the problem, don't worry about sending that key securely yet because you don't know how to do it. In the future, though, I may say the key also needs to be sent securely. But you'll have a new set of primitives for authentication and things like that. And that's called asymmetric encryption, which we haven't covered yet. It is possible, it's just we haven't gotten there yet. All right? Yeah, please go ahead.
So what's the point of the HMAC key? Because you couldn't you do the same thing without the key
You
by
could.
comparing it? So why do we use the key?
More security.
Okay.
You know it as a secret. So just more. All right. Any other question? So, here it's nothing to do with confidentiality, right? It's nothing to do with that. So it's like, here's my software and here's the Mac of it. That's it. And you're just like, I just want to double check that this code has not been tampered with. No one touched it. All right, let's do a couple of these then. So we want to do the SHA1. So SHA1. And there it is. And then the SHA256. And there it is. And you can see it's longer once again. All right. With the idea of that being more secure. Actually, to answer your question, what's your name? Sorry?
Julian?
Julian, yeah. So in crypto, right, in Bitcoin, you have like a password that you create. Like it's got, I forget what it's called, but it's like a whole bunch of secret words that you have. So that's where it would fit. Do you see that? So it's something that's associated that only you know when you start the process. So it's just part of the algorithm. All right. Yeah, so we have this. So that's problem 2. Okay. So very easy, right? OpenSSL is great, as I said. The things that I'm discussing, the math is correct. But the principle of it is correct, but maybe the implementation is weak, right? So you have to be careful with those things. And that's why something like OpenSSL is the kind of thing that you should trust and nothing else, right? To a certain extent, right? Because you never know if these things have vulnerabilities that people have found and they just kept a secret. All right, so we've done that one. Okay. And we did one with the key. Now go ahead and try longer keys also, right? In the problem, just for fun, see what a longer key gives you, right? And report your observations essentially. All right. All right, so now we're going to change one bit of the file, right? So that's going to be our objective. So we need to think of that experiment. Yeah, we're going to use the same hash text. So I'm going to hit clear here. All right, so we just need to pick one of the algorithms. You don't have to do it for all of them. It just says in the problem, corrupted file, create a file and hash it before and after corrupting one bit of the file. Report your results. With this exercise, number 3, I would recommend trying bigger files. Copy some text from Wikipedia, paste it into a file, still just change one bit, convince yourself. But here I'll demo this example. So let's think about it. So I'm gonna pick sure, SHA256. Let's go with this one. So OpenSSL DGSD SHA256 HMAC hash text. So that's the hash number, right? So you send that to your friend, or that's the established hash value. Then maybe an attacker comes in, changes one bit of the file for some reason, or when the file was sent over the internet, one bit was flipped for whatever reason, but the file has now changed a little bit. So what I need to do is I probably need to run ghex, right? And then I need to try to open this file. So it should be this one, right? Hashtext.txt, because that's the one that I'm analyzing. I'm going to try to open it. All right, so that should be in bytes. We want to do this because sometimes, although our current file is a text file, not all of them will be, right? There could be a binary file. So here, this will allow you to modify anything. So let me then, let's go and, right, so this one. All right, so did you guys see I changed from 6F to 6E? So essentially I flipped a bit of it. All right. Right, and now everyone with me? Any questions? All right, so now we should be able to save. And I'm gonna say hash text, but flipped, right? Flipped. All right, so close it. Okay, so I can do ls-l. I have my hash text file original and hash text flipped. Okay, so now we're going to test the integrity of this to see what happens with the hash value. All right, so let's go ahead and do the OpenSSL, but I'm going to add flipped here. We know that we already have the hash value. This is the original hash value, and this is the new hash value. So if you analyze them closely, what would you conclude? Or yeah, go ahead, please. It might be a bit shorter, but I would argue, but look at the values, right? Like, are they like totally different, somewhat different? So totally different. You would lean more towards totally different. Do you guys see that? So that's the example. We can actually look at hash text because there was a hash text flipped. And you can see here is where I flipped the bit, right? You can see that this is a message to be hashed, and that changed to an N. So we just changed it a little with G hex and we got a different hash value. So that's essentially whenever you've gone somewhere and it says here, download the software, maybe download Windows 10 or whatever, and here are the hash values. That's what they're telling you is that like, these hash values, if you download it and hash it and you get that same value, you're guaranteed that no one has tampered with it with like 99.999% certainty. Can't be 100%. Probably impossible, but because there could be, but in general, this is very acceptable. Got it, guys? Any questions? Yeah, so that's it. Pretty easy, right? So that's the three problems. So we have plenty of time. So we'll do the XOR hash. So that's like, it'll take, but we've done the first three problems and now you guys can look at the last problem. So that one I leave to you. And as I said, there's a bit of complexity because you're only allowed to send, you can share the key obviously however you want, but you must achieve both integrity and confidentiality in one shot. Any questions about this problem? Yeah, go ahead, please.
It doesn't have to be perfect confidentiality.
Well, the key, you don't have to worry about exchanging the key. So but yeah, you have to think about how that would work, right? Do you guys have any questions about that? All right, well, all right. So I'll let you, so what we will do today is let's do so this is homework then. I'm gonna create the link, right, in a second, and you'll be responsible for it. And then we'll start with the XOR hash. I'll assign that homework as well, and then I'll just give you time to work on them or ask any questions that you might have. So let me create this link. So it should be, these are the lab problems. All right, so I'm going to create the assignment. So we're going to be doing a week from today. I'm going to call this OpenSSL integrity or hash. SSL hash homework, right? So due date is today's the September 11th, so the 18th by 10 p.m. Start date is going to be, let's say, the 9th, but it will stay open until Sunday. Okay, so you have until that Sunday really to submit your assignment. Right? I strongly suggest that you submit it by the 18th. All right, so I'm just going to say complete the problems. The problems in the attached Word, Microsoft Word document. The attached Word document. Is this clear enough? Everyone understands what they need to do, right? So it's those problems I just showed. All right. So this assignment should now be live. Okay, perfect. As I said, this is pretty easy. But what I like about this, it starts to add that complexity, right? Of integrity, confidentiality, and I will keep doing that, right? So every few weeks, there's just more that has to be done in one shot. All right, and that's why yeah, go ahead, please. Really? Oh yeah, because I haven't assigned it yet. I see what you're saying. That's what we're about to do. Yeah, so you're talking about this one here. Yeah, this is what we're about to do. And once I finish going through this, I will make it available for you guys. Okay? All right, I just keep these because I sometimes make notes on them and I want to make sure I go over everything. All right, so let's take a look. Just to confirm, so this one has been assigned and you have your problems, which are these, okay? And we're responsible for that. All right, so now we should be ready for the XOR. I'm gonna end this video and start a new one so it doesn't get too long here.